you're worried you're going to hit your head and potentially get incapacitated. And you guys have just not had a break lately. Looks like most places that are reporting IFR are also going to coincide with icing conditions. If you aren't IFR capable and rated, you should be nowhere near those areas. Hey everybody, welcome back to AeroSafe, the weather analysis channel for general aviation pilots. My name is Erica Gilbert. I'm a flight instructor and instrument instructor located in Central Kentucky. We look at weather from the perspective of a general aviation pilot. We look at general areas of IFR weather, general areas of VFR weather, and consider the hazards that could exist within those. General aviation pilots, we're looking at people who are flying small piston aircraft that have little to no anti or de-icing equipment and the inability to get above the weather. We use FAA approved sources of aviation weather to help do a few things. One is increase your overall situational awareness. Two is to help educate you and show you how to do an in-depth weather briefing and analysis. And then the third is to help you make a more informed go or no-go decision. Weather is a causal or contributing factor in a huge majority of general aviation accidents, and it's my goal to help prevent you from being in one of those. We'll start off by looking at the surface analysis and see what's causing all the weather that we're going to be looking at. Starting up in the northeast, we have a cold front being pushed down from Canada that becomes a stationary front over the Great Lakes and down towards the panhandle of Texas. Now, there at the panhandle of Texas, we see a pretty big low pressure system. An occluded front connects that low pressure to another over East Texas, where a cold front and warm front meet, and that warm front extends down to the Bahamas. We've got high pressure persisting over the eastern U.S., a trough right over Kentucky, and we see lots of really crappy weather to the east of that low pressure system over Texas. On the rear side of that low pressure, we see a stationary front and a few troughs along the way. High pressure persists over Idaho and the surrounding states, and then right over the coast, we see a mixture of fronts, some stationary front and an occluded front up by Alaska, and then some more low pressure with an occluded and a warm front coming in. Big area of high pressure out over the Pacific Ocean. On my previous video, we had a commenter ask a question, basically asking the difference between a high pressure system and a cold front, and why are they not essentially the same thing? Well, great question, Alan, and let's get into it by talking briefly about what causes high pressure and low pressure. Pressures on the surface, that tells us a lot about how air is moving within the atmosphere. As pilots, we're told how air moves around these pressure systems, but we don't necessarily go into what creates the pressure systems. And to do that, we have to take a step back and up and look at the jet streams. So here we've got the 500 millibar chart, which winds up being about flight level 180. We're going to compare a few things in the jet stream. One is ridges. So a ridge is essentially an area the wind's moving pretty straight. A trough is an area where the jet stream turns. Now, what happens when the jet stream turns is pretty similar to what happens in a creek or river in a turn. On the outside, at least, of that turn, the velocity of the fluid increases. And what happens when the velocity of a fluid increases is the pressure decreases, right? We see the same thing in a perfume bottle. We see the same thing in a venturi, in a carburetor, and we see the same thing over the top of the wings when we're flying. The air increases in velocity, which decreases in pressure. And that pressure differential can be manipulated to get desired results, whether it's produce lift or squirt the perfume out of the bottle. What happens practically in the jet stream is that increase in velocity around the trough creates low pressure. That low pressure is sucking the air up like a vacuum and creating that rising air that we see in low pressure. The opposite is true for the high pressure systems. So in the ridges, which is fairly straight, the velocity of the air is relatively lower. And when velocity decreases, pressure increases. That increase of pressure in the jet stream creates the increase of pressure on the surface. So that's what creates the low pressures and the high pressure systems on the surface. Let's talk a little bit about fronts. What is a front? A front is a line between two distinguishable air masses. Now, if that's the case, if there's inherently warmer air and inherently cooler air where the front meets, how do we know if it's a warm front or a cold front? Well, a front is defined by which mass of air is advancing. Is it cold or is it warm? And what if there is no front advancing? It becomes a stationary front. Cold air inherently has higher pressure because the molecules are more densely packed. We also often see high pressure on the back end of a cold front. For example, up here in Canada, we see a cold front advancing and we see high pressure on the back side of it. Here it's also a stationary front. Now we could reasonably assume that there is cooler air north of the front, warm air south of the front, and there's high pressure on the back. But again, what creates that high pressure are these ridges in the jet stream. That's slower moving air that has a higher pressure because of Bernoulli's principle. High pressure systems often follow a cold front. The two could be said to be linked because cold air typically has higher pressure, but they're caused by different things. Now, when we look at weather in the atmosphere, we have to remember that it is an energy system. No variables operate separately from each other. All variables come in together to play. And I'm not a meteorologist, but that's what makes forecasting so difficult, is there are so many variables and it's not a closed energy system. There's constantly energy coming into and going out of the system through the atmosphere out into space or from space, right? We've got thermal energy from the sun, and then we also have energy that escapes through the atmosphere. So while a cold front and high pressure systems do seem to often go together, they're not inexplicably linked, though they do exist within the same system. Alan, I hope that answers your question to a level of depth that fulfills your need. Again, I'm not a meteorologist, but that's how we can think about fronts and pressure systems. Let's spend some time now looking at the interactive map. If we just take a quick overview, we see that near the center of that low pressure system, there's a large area of stations reporting IFR. When we get into the center of it, we also see some low IFR. If we were to look at Salina Municipal, there's a special observation. 3 statute miles, there is snow, mist, overcast at 400. So at the very center of that weather system that's being created by that low pressure and all those different fronts coming together, we see some really yucky stuff. As we move away from the center of that system, it gets kind of nice, right? Along most of the eastern, so we've got a lot of VFR weather, we've got a lot of stations that are not filled in. They are open circles, which means there is no reported ceiling. And that kind of situation persists all the way down almost to the tip of Florida. Miami is reporting overcast at 2,700. Little windy, gust into 18. IFR weather goes all the way from Louisiana up to the very tippy top of Minnesota and stretches out a few hundred miles there. On the back end of that gross low pressure system, we see some more VFR areas, open circles at stations, which again indicates no ceiling, no clouds at all whatsoever. That persists California all the way up northeasterly through Montana. It's a big swath of nice VFR weather. And then if we look up at the far northwest into Washington and Oregon, we're getting some yucky stuff again. You guys have just not had a break lately. We see IFR and low IFR a couple little areas of low IFR and some marginal VFR and some VFR. The mid-longitude within the country is pretty much IFR. We've got VFR along the eastern coast. We've got IFR up in the far northwest and large areas of VFR. We talked earlier about that stationary front that on the rear side had high pressure up in Canada. This freezing level here, freezing at the surface, pretty much follows that stationary front. Pretty much everywhere above that has an icing air met, an air met Zulu. Between the surface and 6,000, tops are 19,000. If we look over the Great Lakes, similar. We've got severity level of moderate icing, base at surface, top at 6,000. And then this huge swath here, which is related to that low pressure from the panhandle of Texas to the north side of Mississippi, all the way up to Minnesota and North Dakota. If you're in a cloud, you're going to experience icing. So that's going to be a no-go situation. Looks like most places that are reporting IFR are also going to coincide with icing conditions. The only place where there's an exception to that is South Texas and Louisiana. The reason why that's not a problem is because we largely see freezing level at 8,000 feet up to 12,000 when we get to the south part of the Gulf Coast. This air met starts, the base is at 10,000, the tops are 24,000. So if you were in the far southeast and in a cloud below 10,000 feet, as long as you're on an IFR flight plan, you should be perfectly fine. If there's any air met Sierras, no, understandably, those air met Sierras exist in all those areas that we talked about being IFR. We've got one over the northern Appalachians here, air met Sierra over that central part of the U.S., and then here over Colorado to the north and south, mountain obscuration. We've got one little area of IFR in southeastern Idaho, close to Wyoming. The northwest, again, you guys are not getting a break lately. That really sucks. We've got mountain obscuration and IFR. Vast majority of those are going to be icing conditions. So if you don't have anti-icing or de-icing equipment, you shouldn't be in those areas. And if you aren't IFR capable and rated, you should be nowhere near those areas. Air met Tango, T4 turbulence. The green ones are high level turbulence, which is not exactly in our wheelhouse as general aviation pilots. That low pressure system, that's bringing the junk. We've got wind shear and low level turbulence. So low level turbulence between the surface and 18,000, moderate turbulence. Now I've talked about this before. Moderate turbulence is not something that I am willing to fly in a light piston aircraft. Not to mention the icing that's going on in that area. We also have that low level wind shear air met. Airspeed loss or gain of 20 knots or more below 2,000 feet AGL. Now, when you combine low level wind shear with low ceilings, you're running out of room and margin for error. A no-go situation in my book. Low-level wind shear really becomes an issue on takeoff and landing when you're at your VREF, your final approach speed, which should be about 1.3 times your stall speed in the landing configuration. For most light piston aircraft, a loss of 20 knots is going to take you from VREF to, if not below VSO, very, very close. It's a dangerous situation. You add to that a low ceiling, and you could be in a position where you stall close to the ground, no room to recover. We've also got some low-level turbulence up here in the northeast. Moderate turbulence, base at the surface, tops at 7,000. Up in the northwest, same thing. We've got that low-level wind shear and moderate turbulence from the surface to 15,000. California is interesting. We see a couple of troughs going on. Now, a trough is an area of low pressure. Get that stretch of rising air that's pretty unstable. So you could see some development of a little bit of convective activity You get other signs of instability in the atmosphere like turbulence and low level wind shear. Let's see if we have any SIGMETs going on. And we do. All of these are going to be related to that intense low pressure system over Texas right now. So we've got these SIGMETs over Texas. We've got 2 of them. That's for low visibility on that west side of Texas. All of these white areas are going to be convective SIGMETs, and then the grayed areas with the black lines, black dash lines, are going to be convective outlooks. Now, I personally choose not to fly in convective SIGMETs. Areas of several embedded thunderstorms moving at 40 knots, tops above flight level 450, tornadoes possible. So this whole area would be absolute no-go for me. Let's look briefly at pilot reports. Look at all of those that are reporting turbulence and or icing. It's a Cessna 208, which is a caravan. Severe turbulence. Like, you're worried you're going to hit your head and potentially get incapacitated. You know, the main point here is that we see lots of pileups across the central part of the US where we talked about icing, we talked about turbulence, we talked about severe thunderstorms. Definitely pretty much no-go situation for me throughout a lot of this. We'll look a day ahead, and we still have that occluded front that connects those 2 low pressure systems and cold and warm fronts, along with a trough that was going to stretch from western Kentucky up to Pennsylvania. So there's a lot of nasty stuff going on there. It's going to bring a lot of precipitation, chance of thunderstorm through a large portion of the southeast. What just caught my attention is this guy up here. Look at that. It looks like we're in the 980s. Look at how close those isobars are together. That's a huge pressure gradient in a very small area. It looks like pretty much once this system moves out, we're going to be ready to be hit again by another winter storm that's going to be pretty bad. And the lower the pressure, the more severe we can expect the weather to be in terms of wind, in terms of tops of clouds, in terms of that upward development that's going to bring updrafts and downdrafts. So turbulence, thunderstorms. That guy, I'm really interested to see what's going to happen in the next few days. We might be hunkered down for a while. So this is 2 days from now. This is going to be Wednesday. That low pressure system, which one? There's so many of them. Looks like they're predicting it's going to lose a little bit of strength, but we've got a pretty similar thing going on here. We've got low pressure connected to some other low pressure systems by a cold front through the winter. It'll be interesting to see how these systems interact with this warm, moist air over the Gulf. There will be some large areas of VFR weather along the southern part of the US, but that northeast and northwest are going to be pretty yucky. Not only IFR weather, but weather that is severe enough to prevent safe flying from the convective perspective and also from the icing perspective. So being that the next couple of days don't look like flying weather, I'll end with this question. When you're grounded due to weather, how do you maintain proficiency as a pilot? You've got some level of self-motivation and determination to continue expanding your understanding. What else do you do to maintain proficiency? Are you a member of the FAA Safety Team Wings program? Do you do any reading? Do you have a flight simulator that you use? Answer the question below about how you stay proficient when you're grounded due to weather, and I'll send you some stickers. Thanks so much for tuning in. We'll see you next time.